So first of all, thank you for joining us. A little bit about ourselves. My name is Daniel, as I said, and this is Asaf with me.
Hey.
We are both from the Pulse engineering team. And in the next 30 minutes, we're going to talk about a bit performance of UI applications, and especially in React. First, a little introduction about the Pulse. So the Pulse is a SaaS company. We aim to make the work of teams better. And a bit about our engineering. Our client side initially was written using Backbone.js, and over the past few years, we are gradually moving into React. We are now in kind of an hybrid state where we have both Backbone and React running together in production. And the current phase we are in is taking the most and biggest component of our application, we're about to see in a few minutes, and make the transition as well for React. Okay, so this is how the Pulse board looks like. As you can see, this example is actually our iteration board that we are using in order to plan and execute our work in the R&D. So each board in the Pulse is comprised out of groups, and inside each group we have what we call a pulse. You can actually think about it like a very smart table where each pulse is actually a row. The columns of the pulses that you can see, like the status and signee here and epic and so on, are fully customizable, which means that we can have a numerous number of columns, and pretty much we can get really quick to a very complex DOM. So if we jump straight to the end of the story, you can see on the left side our current implementation of the backbone boards, and on the right side you can see our new implementation in React. It's still ongoing. We are developing it in production. And I want you to pay attention to the following example. What we are about to show here is the difference between the two, and I hope it will explain why we are doing such an expensive transition. What you are about to see is actually us trying to scroll all the way down in this board, going over lots of groups and lots of pulses, and I hope you will notice the difference. Okay, so you ready?
Yeah.
Okay. Okay, again I'm reminding, we are trying to scroll all the way down at full speed. You can see that the version of the React boards works smoothly. And we are still waiting, and actually it's a real board, and this is the real difference that we currently have. The left side, by the way, is our own production code. The right side is only for beta users, and we are in halfway there of completing it. So what we are going to talk about in this lecture is our journey of taking this complex and very UI-intensive component and talk about the things we learned while transferring it to React. So as you can imagine, having such a different wasn't easy, and as I said before, it's still an ongoing process, and let's go over the things together.
Okay, so the first thing that we did was moving to React, obviously, because we have experience using the library. Most of our application is already written in React. We love using it, and it usually gives us great performance. Not that one.
Other side.
No. Yep. Okay, so those of you who have experience using React, you probably know that React is usually, for most of the application, is really fast out of the box. The reason why React is fast because we know that JavaScript is fast compared to modifying or querying the DOM. And when you build a React application, you basically build the components of the application. You write what will be the resulted DOM for each component, and then the library takes care of modifying and querying the DOM only when needed. But in our case, it wasn't enough. And you can see in this example that in a huge board with thousands of items, when we click on the pulse or over a pulse or selecting a pulse, all the CSS and the JavaScript animation become really slow. So in order to solve this issue, what we wanted to do is reduce the number of items that are in the DOM at any given moment. So we did it by using windowing. So you can see in the left side, you can see that this is a board with thousands of items, and all of the items are in the DOM. And this is why the CSS animation becomes really slow. So this is also true for applications that are not using React. This is for every web application. And in the right side, you can see that we are using windowing to put on the DOM only the items that the users see. This is how we reducing the number of items that are in the DOM.
Okay, so now that we use windowing, which by the way is a common practice that everyone knows about endless lists, and it's not something very special, we have fixed number of items in our DOM that are rendered on each given moment, which means that we have a pretty decent DOM. Okay, it's something that is not very big. Still, as you saw before and what I explained about the columns, in our case, it wasn't enough either, because although we have small number of items, still each item can be very, very complex, making, again, the rendering and all the animations and everything work slow. So another method that we heavily used, and it's actually not specific to React, but again, a common practice, is what we like to call progressive rendering, or React, in the React jargon, it's like conditional rendering, which means that in every given moment, we render only what we need, and only when we need it. In this example that you're about to see, you can see that here, if we take a closer look on the status columns, then each pulse, each row in the table has a status column. Currently, most of them are done. And I want you to pay attention what happens when I'm hovering above a certain cell. Okay? Pay attention to the DOM below. So, as you can see, as I enter with my mouse and getting out with my mouse, I'm rendering an additional UI elements that weren't there in the initial rendering, okay? And in this practice, when we render only the things we need at the first moment, helps us a lot to render the boards really, really fast. And of course, in scroll, when you always need to render new items that gets inside the window, it also helps to do it very, very fast. So, some tips or some things that we took from the progressive render and used in practice. So the first thing was that when we approached this project, we wanted to have at the first moment a read-only view, okay, or a read-only version of the boards. The reason for that is that first of all, it forced us to render only the minimal things we needed, okay? So it's very, very easy to understand, okay, this is what I need to render now, just to see the board, to scroll it, and without doing any actions or user interaction. And on a later stage, we can add more and more things, and if you do it correctly, we won't harm the performance. It also means that the read-only version is actually gave us a clue about what performance can we gain from this transition. Okay, it's very, very expensive transition, and we wanted to know with just a little of investment if it's worth it. Okay. And the last thing about read-only version in our case was that it was a performance benchmark that we keep along the way, and as we develop new features, we can always look back and say, okay, performance hasn't degraded since we continued and adding new functionality, and it helps us a lot to see that we are in the right direction and that we won't end up with a fully functional board, but very, very slow one. Another important thing that we always keep in our minds when we develop UI applications is that we try to make a very clear distinction between things that are getting rendered, what we call code-generated renders, which means things that are getting rendered in a for loop, in a map, and things like that, as opposed to things that are getting rendered as a result of user interaction. Okay? The first one, which is code-generated renders, must be fully optimized. We dedicate a lot of time to make sure that everything is optimized fully. While in the user interaction renders, this is the place that we can be more, give more place for expensive rendering and try to put everything we can there. This also wraps the things up with the progressive rendering we talked about before.
So now that we know that we have a fixed number of items and each one of them is really simple, we want to talk about improving the performance of the React in our application to get even further high performance. So as I said before, what React does is changing the DOM only when it's really needed. So it needs to calculate the resulted DOM of each one of our components. So if we want to improve the performance of our React application, what we need to do, we can tell the library that some of our components shouldn't change if we want that nothing may have changed. So how are we going to show you that? We're going to show you some examples for principles that we use while developing the boards. This is the beta dialog in which we offer our user to experience new features that we are working on. This is part of our philosophy at the Pulse that we want to develop in production. We want to get feedback as soon as possible from customer. We want to see that the feature that we are working on works as expected. So let's go over the structure of the dialog. You can see that there is an icon and a title for the dialog, and there is a list of items. This is really a basic example to show you the principles that we did during the development of the board. You can see that each one of the items has a status. It can be either off or on, and each one of the features has a button that the user can click on it and change the status of the feature from enabling it or disabling it. Also, an important notice that you can see, there is a trending icon in the faster board feature. This is a product decision that we made, that we want that in some cases that we want to promote the feature. We have one feature that is the most recommended one. So now, after explaining the structure of the dialog, let's go over to the code of the dialog, the components that build this dialog. So the first component is the header component. It gets the icon and the message from the parent component, and based on these values, it presents what you see on the left side. Next, we have the feature item component, which gets the status from the parent component, whether it's active or not. Also gets a toggle feature call that will be invoked when the status of the feature will change. Also, you get the recommended feature ID, which is based on this value. The feature decides if it's the most recommended feature or not. And the parent component, the last one, is the feature dialog, is in charge of rendering the header component and passes the correct props to the header component, and also it's in charge of mapping between all of our features to the feature item in order to render the feature item. This is an example for what Daniel said before about code-generated rendering, because in this example we have only 3 items, but imagine that you have 1,000 items. You can imagine it will be really expensive to render it, so it needs to be fully optimized.
Okay, so let's activate the feature, okay, and see what happens. Yeah. Okay, so imagine that now, by the way, if you take a look, it's a real example. The Fester boards was our first try to optimize the backbone boards, and somewhere along the way we decided we have to start with the React board. But putting that aside, if we take a look, then you can see the diagram of the components here. And now imagine that I'm clicking on the activate button in the Fester board feature. So let's see in our diagram, all the things that are getting re-rendered will be colored at white. Okay, so imagine I'm clicking on the activate button, and as you can see, all the components has been re-rendered. And this raises several questions, because if you remember, for instance, the header in our initial example, then the header is only comprised from icon and a message. So I wouldn't expect that it should be re-rendered when I'm activating a feature, right? So let's first talk about React should component update. I guess everyone that works with React knows this lifecycle method, but in short, this lifecycle method should component update is a method that gets called before the render method in React components. By default, it returns true, which means that it always should call the render function afterwards. And React gave you this lifecycle method in order for you to have better granularity and decision when and if you want to render, to continue to the render method of a certain component. As you can see, you have an access to the next props and the next state, and of course you have the current props and the current state in your, you have it accessible, and then you can do some comparison and return false in case you don't want to proceed to the rendering part. So if we take a simple example of the header and implement the should component update method, you see that we actually want to re-render the header only in case the icon and the message has been changed. If they weren't changed, if the change is unrelated to these props, there's no need to re-render the same component again. And of course, all the examples we show here are things that we use heavily in repeaters and things that each re-render can be very, very significant. Okay, so let's see what happens now after I implemented the should component update and I activate the same feature again. And as expected, you can see that currently the header wasn't re-rendered again. Okay?
Okay, so what Daniel just showed you, it's a basic implementation of the should component update method. So what we did, we basically did a shallow comparison of each one of the props key. So instead of doing it for each one of our components, we can make our components pure, meaning some class that React library offers us. And by default, all of our components will have a should component update with a shallow comparison. So let's go back to the same example of the header component, and let's, instead of implementing the should component update, let's make it pure component. So you can see, by doing this change, now we'll go back to the same example, and we know that the should component update is implemented by using shallow comparison. So we want to achieve the same result as we got before. So let's activate the faster code feature, and as you can see, we got the same result. So we saw that pure components can be really helpful in avoiding unnecessary rendering if you want to improve the performance of our application. So let's make the feature dialog and the feature icon component pure as well. So this is the feature dialog. Then change the feature icon as well. And let's go to the same example. So if we really think about it, if we change the state of the faster board feature, only this item should change, because the React boards and the checklist features items should not change. So if we're going to activate the faster board feature, we want to see only this item get rendered. So let's try it out. Okay, so we see we have a problem here. And so maybe Daniel can fix it.
Okay, so we expected only the relevant feature item to be rendered again, right? So why did nothing was changed? Why all the feature items get rendered again and again? So let's take a closer look at the feature dialog, which is the component that renders the feature item itself. And you can see that we are focusing on a single line here. This line is actually the line that passes the toggle feature callback, which is the action, to the feature items. And as you can see here, what can be the problem? The problem is that by defining the method like this with the arrow notation, okay, we actually define a new function, a new object, each time the feature dialog render method is called, okay? And because React do a shallow props comparison on pure components, it actually sees the different object, the different reference, and thus it renders all the items again, although we didn't really want it to happen, right? Because nothing has changed. The callback is still the same callback, and there's no need to re-render all the items again. So with a simple change that instead of defining a new object each time, a new function each time, we just pass the reference that we got from our parent component, And this way, the reference stays the same, the function stays the same object. And if we go back to our example and activate again the faster boards, you can see that we got exactly what we wanted and what we intended at the beginning, right? Because only one feature item has been rendered, the one that got his props really changed. So this can be very significant from our experience especially when you deal with complex UIs and things that are coming in repeaters and things like that. It can have significant effects on the performance. Think about that each render that React does, although it doesn't touch the DOM in that point, it still creates lots of JavaScript objects, it executes lots of JavaScript code, and of course, garbage collection of all the objects that are being created that can all be very expensive when we are dealing with lists and things like that. So another common pitfall that illustrates the same problem exactly is a common situation where we want to pass as props only an optional information. So many times, at least in our code, you can see something like that. For example, we want to have an extra info that is not always available. So in this case, if it's defined, we are passing it as props, and if it's not defined, we are passing an empty object. The problem here is similar because we actually define a new empty object each time, causing the props to change again. Okay, and this is a very delicate example, but it's things that you should keep in mind when you're dealing with these kind of things. The solution for this is very simple. Define a const of an empty object and pass it instead of creating a new object each time. And in this case, React Pure component will do a shallow props comparison and everything will be okay, and you won't get re-rendered unless the data has really changed.
Okay. So after we fully optimize our activate and deactivate flow, let's talk about another flow. Let's imagine that the most recommended feature changed. So let's go back to the example. Okay, at the moment, only the faster board feature is the most recommended one, and this is why it has this icon. But let's assume that the React board feature now becomes the most recommended one. So we know that two items should change. Let's check it out and see what will happen. Okay, so as you can see, also the checklist feature got rendered. So let's see what we did wrong in the purpose of avoiding the rendering of the checklist feature. So we are back to the feature dialog component, and we're going to focus on one line. So you can see that we passes to each one of the feature items, we passes the recommended feature ID. So if the recommended feature ID will change, each one of the item props will change. And therefore, even though the items are pure, they will get rendered. So if you want to do something smarter, we know that each item only need to know if it's the most popular or not. So instead of passing the recommended feature ID, we can pass a Boolean value saying to the item if it's the most recommended or not. So let's change it. Okay, now let's go back to the same flow, and we know that at the moment the checklist feature item is not the most recommended one. So let's assume again that the most recommended feature changed. Let's see what happened. Okay, as expected, we improved this flow as well, because the checklist props haven't changed, because the checklist remained not the most recommended feature.
Okay, so to sum things up, here's a small cheat sheet of the things we talked about, and I think you can definitely take it to your applications. Of course, it's not always suitable, but in the places when performance is very, very crucial, it can help a lot. So, as we said, the first thing is to always try and minimize and simplify the DOM, especially in repeaters, as we talked. This can have a significant effect on CSS animations, on performing JavaScript operations and things like that. The second thing is always put your effort and focus on optimizing renders that happens a lot. Okay? If some render happens when the user hovers above a certain element, it's not really interesting because it's user interaction related and it actually can't affect that much. But everything that is inside the code, inside the for loop, can be very, very damaging to your performance. The third thing is to use pure components. We believe it's something that React has given us as part of the library, and it's basically a very, very useful thing. It's almost always the things you expect to happen, and especially if you work with immutable data structures, then you know that nothing will change without the shallow comparison be different, and it guarantees that everything will work as expected and render only when things are really changed. The fourth thing is try to avoid from defining new objects when passing props. It can be either, as we saw, with callback functions, it can be with empty objects, and there are a lot more examples. This thing actually messes up all the intent behind shallow props comparison and causes a lot of unnecessary rendering. And the last thing is what we saw with the most recommended feature ID. You should strive always to pass to child components the minimal information they need. Okay, there is no need to pass more information than what the component should know. In our case, we saw that instead of saying, okay, this is the recommended feature ID for every feature item, we just keep the feature item very, very stupid, and we say either you recommend it or not. And this thing helps you as well to make sure that the components will actually render when they actually change. That's it. We want to say thank you for listening.
Thank you.
Two more last things. The first thing is that we have on the Pulse blog, we have lots of engineering articles there, and actually we are starting to write a captain's log about the transition of the boards from Backbone to React. So I think the first post will be up in 2 days or so, and I really recommend to read it. It has lots of important insights also about the process and the planning and things like that. And the last thing, of course, we are hiring for lots of positions in the R&D, so feel free to contact us. And we always love talented people to join us. Thank you.
Thank you.
Let's. Yalla.